Well, hello, second grade. It's a pleasure to be with you. So this video is going to be about science, okay? So I hope you're doing well. I hope you're doing well. And let me tell you that it's a different way to teach, but as you know, it's going to be good for you because you're going to learn a new topic about science, which is the subject in this case, in this class. It's important to know something about our planet, okay? So that's why the topic that we have today is about ice, okay? Ice on Earth. So we have to take care of the ice that is in the earth because the consequences are going to be really bad for our planet. So now, the first thing that I'm going to do is to share some slices with you, and you're going to see the information that I have for you. As well, you have that information in your book, okay? So, first of all, I'm going to project a slide with you, but let me check the slices, okay? So here I'm going to put it this way. Then I'm going to share with you this one. This is the presentation, is a topic that we have to see during this class, okay? Second grade, very good. So the topic that we have is ice on Earth. If you can see the background, okay, the background of my slides, you can see it's ice. It's covered by ice. So ice is a state of the water. In this case, this is water, okay? It's a state of the water which is solid. We can see a lot of ice over here and they obviously have a special name, okay? Very good. So the title, the topic of this class is Ice on Earth. Very good. Let's start with the first slide. And here we have you can see a large sheet of ice, which is called glacier, okay, glacier. It is called glacier because it's large and is built by water, which is in a solid state. And obviously it is ice, it is extremely cold. And here you can see, you can appreciate water, okay, some water that is surrounded by this sheet of ice, which is called glacier, okay. You can see, obviously it's dangerous to be in this zone, but as scientists who have arrived to these places, they have special equipment. Then, next one. Next one. This one is an iceberg. It is a big mass. Okay, you can see it's a big mass of ice, which is called iceberg. And this one is on the water. You can see it's on the water. It can float. It can float. And it's a big mass of ice. And this one obviously runs downhill runs downhill, and you can see some icebergs in the sea. Okay, very good. Iceberg, this one. The differences about glacier and iceberg is that an glacier is a large sheet, okay? It's like a page, a big page of ice, but of course it's a sheet of ice. And an iceberg is a mass, okay? It's a mass where we can see the water in a solid state. Then here I have a image which is projected by a satellite, and it says satellite image of glaciers. And here, guys, you can see the globe or planet. In here, this is the planet, and in here, all this white color is the glacier that is nowadays in our planet, in our globe. And we have to see that is a big amount of glacier in our planet, okay? Here you can see water, and there's glaciers over here, and there's a big percentage of glacier in our world? Well, next one. And here you have this page. You can find this information in your book as well in page 106. 106. You can find the information in here. And this information is essential for you because this is a title and this information we are going to read, okay? Well, first I'm going to read and you can follow the reading while you are watching this video in order to see the information. We are going to analyze the information in a while, okay? So please follow the reading with me while I'm reading here. Ice on Earth. This is the title. It says, not all Earth's water is liquid. Water can be solid too, okay? As I mentioned, water is liquid. As we know, we can drink water, we can find water in the river, we can find water in the lake, in the stream, obviously in the sea. But now we are going to see the water in a solid state, okay? And in this form, in an ice, okay? Ice, this is water that is solid. Solid water is called ice. Here you are. Solid water is called ice. That's what I was mentioning. Some places on Earth stay too warm for ice to form. Other places, such as the North Pole and the South Pole, are cold. Okay. And here in these places, North and South Pole, there is not so many humans living there because it's extremely cool. Only some people who live there, they take care of their health, and obviously they use the appropriate cloth, but there's no people who can survive in these conditions. Okay, as we do in here, we use your casual clothes, but in these places, people people use in special clothes. Okay, and water is frozen year round at the poles. Mountains are usually cold places. Of course, if you climb a volcano or a mountain, it's gonna be cold. There are patterns of snow and ice that can be observed. In mountains, snow can build up into layers. Over time, the icy layers become very thick. Okay, they become very thick, and these thick sheets of ice can slowly move downhill like rivers of ice. These moving ice sheets are called glaciers. That's what I was mentioned before in the picture about glacier. That is a sheet that is called glacier, is built of ice, which is water. And sometimes glaciers reach the ocean. When this happens, large chunks, which is the mass of ice called icebergs, can break off and float away. Okay, here we have two important concepts. Okay, glaciers and iceberg. The difference is we have seen glacier, that is a sheet, that is a large sheet of ice. And iceberg is a chunk of ice that we can see floating on the sea. Okay, so this information that is important that you read again, guys, if you really need to do it, because you are going to need it for some activity later. Okay, very good. Here in this part says this iceberg is near Greenland. One of the largest Greenland is found on Greenland. You can see here in this picture in your book that the largest glacier is found in Greenland. It's a place where we can find the largest glacier. Okay, very good. Then here I have two questions, guys. In your science notebook here, Ice on Earth. This is the title. Remember to write down the virtue, date, and TKC all the time. The title is Ice on Earth. Question number one, where can Earth's water be found? Okay, we have to think where we can find water. You give me your answer and write down below to the question and tell me where we can find or where the water can be found in our planet. Number two, where on Earth can be the pattern of water as ice can be found? Okay, an important question. And if you really need, you can read again the text that we read before and you can find the answer, because I need the places where we can find ice, okay? Ice. And then you will say that ice can be found in a certain place, okay? Question number one and question number two. As soon as you finish, please send it to my personal account, okay? Very good. I'm going to stop these slices and then I'm going to show you guys, a video about the importance of glaciers, of iceberg, in this case, the importance of ice on Earth. Okay, there you are. Very good. Here we go. I'm going to play this video for you, and you are going to see the importance of this one.
Many people have wondered what would happen if all the glacial ice on the planet melted. Some believe that it would be a water world with no land in sight, while others think that could never happen. But the Earth is changing in more ways than you might think on its own. Many might wonder how much of the Earth's current global warming trend is affected by humans. Regardless of who is to blame, whether the planet is just going through a natural phase in its evolution, or if we are responsible, the evidence shows that the planet is getting warmer and warmer every year. But just how much of the planet could end up covered in water if all the glacial ice melted? Well, it turns out that all the ice melting would just be the beginning of our problems, as many more catastrophic things would happen. You all probably know by now that about 71% of the Earth's surface is already covered in water. But it wasn't always this way. Between 2.4 and 2.1 billion years ago, the planet's water was frozen in an ice age called the Huronian glaciation. The early stages of this ice age was severe, and the entire Earth was frozen over like a giant snowball. This was likely triggered by a 250 million year lull in volcanic activity. Less carbon dioxide in the air meant a reduced greenhouse effect, resulting in a much colder climate. The interesting thing is that during the 200 million years of the Cryogenian period, the Earth was plunged into the deepest cold that it had ever experienced. And it is theorized that the emergence of complex life may have caused this. The theory is that this glaciation was triggered by the evolution of large cells and possibly multicellular organisms. These organisms would have sunk to the seabed floor after perishing, sucking all the CO2 out of the atmosphere, further weakening the greenhouse effect, which lowered global temperatures even more. Yes, even in theory, life forms can cause a global ice age. There is evidence that the planet's ice came and went in regular cycles, and that it's possible that it was driven in changes in the Earth's orbit, as well as what happened on the surface of the planet. When plants emerged and started to cover the Earth, they too pulled the CO2 out of the atmosphere. The reason we mention all of this is that regardless if we are or aren't responsible for the Earth's warmer climate today, evidence shows that the Earth goes through its own cycles of on and off ice ages. But it also proves that life can be responsible for changes in global temperature. The Arctic isn't the same as it was today as it was, say, 100 years ago. Temperatures there have been rising at twice the normal rate, which has been sparking some very alarming changes, unlike anything seen in recorded history. 87% of Antarctica Peninsula glaciers have melted since 1945. Now the region's sea ice is declining by 13% each decade. Scientific predictions that foresaw an ice-free Arctic Ocean during the summer between 2040 and 2050 may come to pass even sooner than we thought. The reason is that satellite estimates for sea ice thickness were overestimated by 25% due to the saline properties of the snow cover on top of the ice, which affected the accuracy of the readings. With that in mind, we can expect the ice to melt much sooner, and that's a scary thing. The oceans are also soaking up more heat. If the oceans become too hot, they will be unable to support marine wildlife because of the decline in oxygen. If all the glacial ice from the poles and the mountaintops melted right at this moment, ocean and sea levels would rise by more than 215 feet. There would be new shorelines, and many places on Earth would go underwater. A lot of people will think, well, that's no big deal. Just get everyone to move to higher ground. Sounds like a simple solution. However, aside from the fact that billions of people would be displaced, there would be more to worry about now that all the Arctic ice has melted. What is not commonly known is that the Earth's poles not only get less direct sunlight than lower latitudes, but the sea ice is white and therefore reflects most of the sunlight that hits back out into space. That reflectivity, called albedo, keeps the poles cold and limits the heat absorption from the sun. That sea ice also influences the ocean's currents, which have a big effect on our weather. The reason is that oceans and air act like heat engines, which move heat to the poles in a constant quest for balance. Ocean currents move this warmer water along what you would call a global conveyor belt in a process known as thermohaline circulation. Without getting too technical, warming up the poles would disrupt Earth's overall heat flow, throwing weather out of control. It's no surprise that global warming has boosted severe weather in general over the decades. Massive hurricanes could form because there would be no sea ice, which limits the amount of moisture that moves from the ocean into the atmosphere. And super tornadoes, more powerful than any ever recorded, would touch down in many parts of the world. Another thing that sea ice does is insulate the air. It does this by limiting how much of the planet's warmth rises up to the surface and from the warmer water entering the poles. When sea ice melts and cracks, it becomes dotted with gaps, which lets this heat escape. But that's not all. Scientists have known for a long time that Arctic tundra and marine sediments contain large frozen deposits of methane gas, which, if released into the atmosphere, will increase greenhouse gases. So, as the Arctic sea ice melts, this source of methane will increase. Think runaway greenhouse effect, which likely helped destroy the atmosphere on Mars, along with the solar winds that strip the planet of its atmosphere. All native forms of wildlife, including polar bears and Arctic seals, which use the sea ice for everything from giving birth to using it as cover to catch their prey. Walruses also use the sea ice as a place to gather. With the sea ice gone, it would force them to overcrowd beaches, and they would have to swim farther to find food. Ice-free waters also absorb more CO2, which makes the ocean more acidic, reducing its carrying capacity for calcium carbonate that shellfish and corals need to build their shells and skeletons. The 9 million people who live in the Arctic would now have to contend with coastal erosion, thawing permafrost, warmer temperatures, and changes in the animal and plant species that some traditional lifestyles depend upon. But that's not all. During this time, there could be massive earthquakes if the ice melted fast enough. One of the more uncommonly known things is that all that ice has some serious weight and suppression to it, and it has been holding down the Earth. And global warming has already bled the frigid continent of about 2.7 trillion tons of ice, with over half of those losses occurring in the last 5 years. This loss of ice has already raised global sea levels by almost a half an inch. That doesn't sound like much until you realize how much ice has already melted. The Pine Island, Thwaites, Haines, Smith and Kohler glaciers, located in the Amundsen Sea embayment of West Antarctica, have all risen by a process called glacial isostatic adjustment. As the ice thins, the land immediately underneath the ice sheet quickly springs back in response to the loss of weight. A study showed that as the glaciers of Antarctica retreat, the land beneath is rising up 5 times faster than anyone thought, meaning that in 100 years, the land will be up 32 feet higher than it is today. And here is what it looks like. The amount of ice that has melted since 1992 until now has increased exponentially, and it is estimated that the rate of ice loss is 219 gigatons per year. That's 219 billion metric tons. That's a huge number to wrap your mind around. But we can use Olympic-sized swimming pools, which require 2,500 metric tons of water to fill. Every second, Antarctica loses roughly triple this mass. This means that every 40 hours, Antarctica loses 1 gigaton, or 1 billion tons of ice. That's enough to fill 400,000 Olympic-sized swimming pools, which, if you put to scale, would equal New York's Central Park. Now imagine that for this 25-year period between 1992 and 2017, that Antarctica lost 109 gigatons of ice per year. That adds up to 2,710 gigatons of ice that is turned to water. You might be wondering if there's anything you can do to help stop global warming. Most climate scientists agree the main cause of the current global warming trend is human expansion of the greenhouse effect, warming that results when the atmosphere traps heat radiating from Earth towards space. The industrial activities that our modern civilization depends upon have raised atmospheric carbon dioxide levels from 280 parts per million to 400 parts per million in the last 150 years. The United Nations said that a scientific panel concluded that there is a 95% probability that human-produced greenhouse gases, such as carbon dioxide, methane, and nitrous oxide, have caused much of the observed increase in Earth's temperatures over the last 50 years. Some of the things you can do are to buy anything reusable and be conscious of garbage and waste, and try to recycle everything. Saving gas by walking more or taking the bus can help, as well as planting trees. But it takes more than just a handful of people to make a change. It takes everyone to make an impact. Perhaps humanity will embrace this global threat on our planet, and governments will act fast enough to possibly reverse the damage. And for those people who procrastinate, the time for action is now, because we may just have an ally in our own sun. A periodic solar event called a grand minimum could overtake the sun perhaps as soon as 2020 and last through the year 2070. The results of this are diminished magnetism, infrequent sunspot production, and less ultraviolet radiation reaching the Earth, all bringing a cooler period to the planet that may span 50 years. The last time this happened was during the mid-17th century. It was called the Maunder Minimum and lasted between 1645 and 1715. During a longer span of time, when parts of the world became so cold that the period was called the Little Ice Age, which lasted from about 1300 to 1850. However, scientists have said we are unlikely to see the return of the extreme cold from centuries ago. But in the case of global warming, all of mankind should take advantage of any help we can get. It was Lyndon B. Johnson, the 36th President of the United States, who was quoted as saying, "If future generations are to remember us with gratitude rather than contempt, we must leave them a glimpse of the world as it was in the beginning." We hope you enjoyed the video. Do you have any idea on how we could stop global warming? Let us know in the comments. If you enjoyed watching this video, then make sure to like,
All
subscribe,
right.
and
I'm going to stop in here because the information that we have seen, guys, is important, okay? I'm going to stop in here, and the video that you have already watched is about the importance of ice, important the icebergs, and importance of lasers in our planet. So we have to take care of them because the global warming is increasing nowadays, and it is terrible. Probably in the video you saw that if the iceberg, the glaciers, they melted, probably the volume of water is going to grow up, it's going to increase, and there's going to be a big problem for us, for living humans. So that's important, guys. Watch the video again if you really need it. Watch this video, this class, and please, the activity is to answer the question that we saw in the slides. So answer them, and as soon as you finish, please send it to my personal account. Okay, I hope you enjoyed the video. If you have doubt, then we are going to answer in the online class. So thank you for watching, guys, and see you later. Okay, bye bye.